Imagine a machine the size of a living room, humming with vacuum tubes, arguing over chess moves. Then flash forward to the phone in your pocket, writing poetry in seconds. How did we race from clunky wires to near-human prose in barely 3 generations? Stay with me, because the hidden detours, epic rivalries, and jaw-dropping breakthroughs of artificial intelligence will change how you see every screen you touch from this moment on. Birth of a bold idea. In the sweltering summer of 1956, a 29-year-old mathematician named John McCarthy rented a Dartmouth College classroom, circulated a 2-page proposal, and coined the phrase artificial intelligence. His audacious promise: every aspect of learning or any other feature of intelligence can, in principle, be so precisely described that a machine can be made to simulate it, did more than launch a conference. It lit the fuse for an entire scientific era. McCarthy's declaration mattered because it reframed computers from souped-up calculators into potential thinking partners, luring pioneers like Marvin Minsky and Claude Shannon to join the quest. The human behind the vision. McCarthy's confidence was forged by hardship. A frail child who missed school for months with respiratory illness, he devoured advanced math texts at home, skipped several grades, and entered Caltech at 17, only to be suspended for ignoring gym class. Undeterred, he earned his PhD at Princeton and later created Lisp, the language that still powers AI research today. His personal life carried equal drama. In 1978, his wife, mountaineer Vera Watson, died on Annapurna, a loss that reminded him, by his own admission, that machines might someday emulate logic, but never human vulnerability. That blend of intellectual daring and lived fragility set the emotional tone for AI's turbulent journey ahead. First sparks, 1956 to 1969. Artificial intelligence began as an academic dare. In the summer of 1956, John McCarthy's Dartmouth workshop declared that every feature of human intelligence could, in principle, be simulated by a machine. His manifesto turned computers from glorified calculators into potential thinking partners, and the field's first research programs sprang up overnight. 2 years later, psychologist Frank Rosenblatt unveiled the perceptron, an electromechanical network of weighted switches that could learn to recognize printed letters, proving that machines might adapt rather than simply compute. By 1966, Joseph Weizenbaum's ELSIA, a deceptively simple script that mirrored users' words back at them like a Rogian therapist, showed that even pattern matching could feel uncannily human. Hope, hype, and the first winter, 1970 to 1987. Early promises outpaced hardware, and in 1973, Brent's Lighthill report blasted AI as an academic cul-de-sac. Funding evaporated. Journalists coined the term AI winter. Yet the field thawed sooner than expected. Rule-based expert systems found a niche inside corporate walls. Digital Equipment Corporation's XCon, launched in 1980, encoded 2,500 hand-built rules to configure VAX mini-computers and soon saved DEC tens of millions of dollars each year. Knowledge, not learning, carried the torch for the next decade. Proof that symbolic reasoning could still pay the bills when learning algorithms stalled. Silicon Muscle and the Second Chill, 1988 to 2004. As silicon accelerated, brute force returned. IBM's Deep Blue, a room-sized supercomputer stuffed with custom chess chips, defeated world champion Garry Kasparov in 1997, a televisual moment that suggested thinking machines might finally be competitive on Grandmaster turf. Yet real-world applications lagged, and investors again grew impatient. By the early 2000s, statistical language models plateaued. AI slipped into its second, quieter winter, kept alive mostly by academic curiosity and niche industrial optimization. Data-driven renaissance, 2005-2015. Salvation came not from clever rules, but from mountains of data and powerful graphics cards. In 2012, AlexNet, an 8-layer convolutional neural network trained on the ImageNet database, crushed the world's premier image recognition contest, slashing error rates by a third. GPUs, designed for gaming, turned out to be perfect for parallelizing matrix math, and deep learning sprinted past decades of incremental vision research in a single season. This breakthrough reshaped every branch of AI: speech, translation, recommendation, and eventually self-driving perception, all adopted the same layered template. Superhuman moments, 2016-2021. When DeepMind's AlphaGo beat 9-dan champion Lee Sedol in 2016, commentators called it a moon landing for machine intuition. AlphaGo's secret sauce, deep neural nets guiding Monte Carlo tree search, blended pattern learning with look-ahead planning, hinting that strategy itself could be learned. Spin-offs soon mastered protein layout, chip layout, and StarCraft. For the first time, researchers spoke openly of human plus performance, and Silicon Valley's appetite for bigger models became ravenous. Foundation model explosion, 2020-2025. OpenAI's GPT-3, released in 2020 with 175 billion parameters, stunned users by drafting code and essays from a single prompt. 3 years later, GPT-4 vaulted into the 90th percentile of the US bar exam, cementing large language models as general-purpose reasoning engines. Meanwhile, Meta's open-weight Llama 3 and Google DeepMind's multimodal Gemini 2.0 Flash post context windows toward 1 million tokens, letting models juggle books, images, and voice in one conversation. In July 2025, Mistral's CodeStro 258 debuted as a code-native model with 256K token recall, an AI pair programmer that remembers an entire repository. Together, these foundation models signal a shift from task-specific tools to adaptable digital colleagues, setting the stage for agent systems that plan, execute, and refine on our behalf. Perceptron to pause. The field's first big uh-oh came after early hype around Rosenblatt's perceptron. In 1969, a rigorous critique showed single-layer perceptrons couldn't solve even simple logic like XOR, an unexpected ceiling that helped trigger the first AI winter. Optimism didn't die, it went underground, forcing researchers to rethink depth, representation, and mathematics. ELIZA's mirror. Joseph Weizenbaum built ELIZA as a demo, yet users poured out feelings to a script that merely reflected their words. The shock wasn't technical, it was human. If people bond with pattern matching, the stakes aren't just accuracy, they're psychology and ethics. That realization seeded today's concerns about trust, empathy, and misuse. Deep Blue's lesson. When IBM's machine beat Garry Kasparov in 1997, many assumed general intelligence had arrived. The twist? Deep Blue didn't think like us. It specialized, searched brutally well, and exploited hardware. The turning point was not human replaced, but narrow AI can dominate well-structured domains. The divine rebuttal. AlphaGo's domination in 2016 felt final, until Lee Sedol's creative Move 78 produced the lone human win. The surprise wasn't that AI was strong, it was that human ingenuity could still find openings. That tension, specialized superhuman AI versus human creativity, sets the stage for today's agentic systems and tomorrow's surprises. Today's AI landscape looks nothing like the chilly labs of the last winter. On the proprietary side, Google DeepMind's Gemini 2.0 Flash, a latency-obsessed model that juggles text, images, and audio in real time, entered public preview late 2024 and rolled out broadly by February 2025, signaling an agentic era where one model can reason, listen, speak, and generate on the fly. Meanwhile, the open-source camp roared back when French startup Mistral shipped CodeStral 2508 in July 2025, a code-native transformer with a stunning 256K token context, built for fill-in-the-middle editing of entire repositories at lightning speed. Regulators are sprinting to keep pace. The EU AI Act, in force since August 2024 and now entering its second enforcement wave, imposes transparency and risk management rules on general-purpose models, with fines up to 7% of global turnover. Across the Atlantic, the U.S. Executive Order FE 14110, October 2023, directs agencies to audit safety, watermark outputs, and guard critical infrastructure. What's next? Sparse mixture of experts networks promise larger capabilities without gargantuan energy bills. Edge-tuned nano LLMs already whisper inside smartphones and IoT hubs, and bio-AI hybrids are rewriting protein design at pandemic speed. Together, these trajectories hint that tomorrow's breakthroughs won't hinge on size alone, but on orchestration. AIs collaborating with one another and with us to tackle problems neither could solve solo. Artificial intelligence has sprinted from clattering relays to code-writing companions in just 7 decades. Yet its most important chapters are unwritten. Each inflection point, from perceptron disillusionment to AlphaGo's divine defeat, reminds us that progress is rarely linear. It zigzags through winters, wonders, and human ingenuity. Today, multimodal agents whisper through earbuds, draft legislation, and design medicines. But they also force uncomfortable debates about bias, labor, and control. Tomorrow's breakthroughs may hinge less on brute scale than on symphonies of smaller models cooperating, retrieving, and reasoning together, mirroring our own social minds. So pause for a moment. If machines can already translate novels, predict proteins, and co-author code, what surprising new Move 78 might humanity play next? Where do you see the next seismic shift? In climate science, creative arts, or a realm none of us has imagined? Which era blew your mind most? The Dartmouth Dreamers, Deep Blue Silicon Grit, or the GPT-4 Quantum Leap? Jump into the comments and share the moment that made you gasp, plus the breakthrough you'd like me to unravel next. If turning tech history into living stories is your vibe, you already know where the follow button lives. While you're here, check out the playlist on hidden innovators and tomorrow's ideas, perfect for any coffee break or commute. Pass this episode to a friend who still thinks AI is pure sci-fi fantasy, and let's keep this conversation rolling forward together.